Okay, this is the second half of the recording for Alg1. So today we're learning about independent and dependent variables. So the variable that represents the input value of a function is called the independent variable. All right, so it's the one you plug in as the independent variable because it can be any value. It's independent. You get to choose any value in the domain and it's okay to use. Now the output value is dependent. And the reason it's dependent is because how you get the output is it depends on what you plug in. So it depends on the independent variable. So you get to choose the number you plug in, that's independent. And what it gives you is the output, and that's dependent because whatever it gives you depends on the number you put into the equation. All right. So when they say this statement, y is a function of x, it tells you y varies depending on x. And so what that means is y is dependent on x, so x is independent. So when it gives you that wording, you can look up and figure out, okay, so y is dependent and x is the independent. All right, so this is a real life problem. It says the water pressure is 0 psi. Psi is pounds per square inch. So that's the water pressure at sea level. And it increases about 0.44 psi every foot an object descends in the water. Descends means to go down. So what it means is, if you kind of picture this, if you're at sea level, it's 0 pounds per square inch. And as you go down, every 1 foot you go down, if you go down a foot, then you go up, you increase to 0.44 pounds per square inch. Sorry, those are fours. All right, so does it represent a function? Okay, so it's yes. And the reason why is because the water pressure changes with any change in like your depth. So each depth of the ocean, every amount you go down has a different water pressure. So each input has exactly one output. All right, so your water pressure depends on how deep you are in the ocean. So if you think about it, how much water pressure you have depends on how deep you are. So that tells me that water pressure is dependent. And that means that the depth of the ocean is independent. So you can choose any depth of the ocean, but based on that depth, the water pressure is going to change. All right, so it says, a whale dives from 1,000 feet to 3,500 feet. Find the domain and the range. Okay, so I'm just going to make a table because it's easier to look at. So your input is your x, and that was depth. Remember, depth was independent, so that's your input. Your dependent was water pressure, so that's your output or your y value. All right, so the well starts at 1,000 feet. That's how deep they are. And they go to 3,500 feet. Okay, so remember what it says. It is about 0.44 psi for every foot in the water. So if you have 1,000 times 0.44 psi, that gets 440. So what that means is if you're 1,000 feet deep in the water, it's 440 pounds per square inch of water pressure. So if you're at 3,500 feet, times that by 0.44, and just do it in a calculator, I don't know this in my head, it's 1,540. Okay, so if we want our domain are the input values. The well goes from 1,000 to 3,500 feet. So the domain is from 1,000 all the way to 3,500. Now the range are your output values, which in this case are 440 to 1,540. So the Y values go from 440 pounds per square inch all the way to, at its deepest point, it's 1,540 pounds per square inch. Okay, so remember that independent is going to go with X or input, and dependent is going to go with Y or output. That's kind of the key there. And domain goes with input and range goes with output. Let's try another one. Okay, you range coins in stacks so that every stack has, it says, twice as many coins as the previous stack. All right, the first stack has 2 coins. So let's just think about this. I'm just going to make a little chart so we can think about this. If I have the first stack, stack number 1, has 2 coins. Now it says each stack has twice as many coins as the previous stack. So stack number 2, we doubled the coins, it now has 4. Stack number 3, we doubled the coins, it now has 8. Stack number 4, double the coins, 8 times 2 is now 16, and so on, okay? So it says, is it a function? Okay, yes, because every single stack number will have a different number of coins, so that means each input will have exactly 1 output. So the number of coins in the stack changes with each stack number. And so that means each input will have exactly 1 output. Okay, so the independent variable is the stack number, because you can choose any stack number. And then based on that number, you're going to find out how many coins. So the dependent variable is the number of coins, because how many coins you have depends on which stack number you're on. All right, it says here you have 6 stacks of coins. So let's go ahead and finish this table because we were so close. So remember, it's doubling every time. So 5 would be 32 coins and 6 would be 64 coins. Now, when we do domain and range, remember that domain is the independent variable, which is the stack number. Range is the dependent variable, which are how many coins. Now, this one is going to be like a scatter plot, because if you picture it, on the well, when the well was going down in the water, the well doesn't just magically go from 1,000 feet to 3,000 feet, right? It's got to like go down in a continuous way. Now, that being said, the stacks of coins, we just literally have a stack with 2 coins. So picture like a stack with 2 coins, and then a stack with 4 coins, and then a stack with 8, and so on. So it just kind of jumps. It's like a scatter plot. So when it's a scatter plot, remember that when we're doing domain, we list them off. So we're going to do 1, 2, 3, 4, 5, 6. And when it's range, we're going to have 2, 4, 8, 16, 32, 64. Because it's not like a continuous amount. Each stack has a unique amount. It's not like the whale where he doesn't just magically disappear down to 3,500 feet. He has to go all the way down across every foot in the ocean. Well, these, we can just make a stack of 4 coins and then a stack of 8 coins and so on. Okay, so last one is the average head circumference of a human at birth is 35 centimeters. Okay, that's how big around their head is. It increases by about 2 centimeters each month during the first 3 months after birth. Okay, so does it represent a function? Okay, yes, because the head circumference is going to change as the months increase. The baby's growing. So the head circumference, like how big around the head is, changes as months go on because the baby's growing. So that means that the independent variable, I will tell you in general, time is always independent because you can't control time. So the number of months after birth is the independent variable. Now, how big the baby's head is, the head circumference, depends on how many months the baby has had to grow. So the dependent variable is the head circumference. Now, think about if this would be a scatter plot or if it would be continuous, okay? So it says a baby has a 2-month checkup. Find the domain and range. All right, so at 0 months, remember the baby at birth starts at 35 centimeters. And circumference. At 1 month, remember it increases 2 centimeters, so now it's at 37. At 2 months, it's at 39. And I quit there because it said it has a 2-month checkup. Now, keep in mind that when you're thinking about this, this is not really a scatter plot because picture the baby's head growing, okay? So if you were sitting here and you were graphing this, and like, let's just say this was 35, and then at 1 month, it's 37, and at 2 months, it's 39. The baby's head wouldn't just magically, like on its 1-month birthday, gain 2 centimeters. Like that'd be so weird. It wouldn't do that. It's slowly growing all month long. So it's continuous, meaning that it's all connected. So when we do the domain, remember the domain is the independent variable, which is months. And when we do the domain, it's going to be from 0 to 2, and it's not going to be listed out. It's going to be an inequality because it's continuously changing. When we do the range is from 35 to 39, and once again, it's an inequality. It's not with commas. And the reason it's not listed out is because the head doesn't just randomly change each month. It continually slowly changes. The points are just like what measurements you had every month. So it'd be really weird if the baby's head just went from 35 to 37 to 39, just like all of a sudden. That'd be crazy. This is our graphic organizer. If you were gone yesterday and you need to fill this box out, pause it and do so. Same thing with this. If you did not get the domain and range box filled out the previous day, go ahead and pause and fill it out. All right, and so we need to fill out independent and dependent. All right, so if it was independent, that's the input. And remember, the independent variable can be any value. Also, it doesn't have to be time, but if time is a measurement in whatever you're doing, time is always independent. So like minutes, seconds, months, years, any measurement of time is always going to be independent. All right, now dependent is the output, and it depends on the value of the input, which happens to be the independent variable. Okay, so pause and write that down. Make sure your name's on this graphic organizer, and we will continue to fill it out as we go.